We learned that radiation is all around us. We also learned that there are natural sources of radiation on the ground, in the sunlight, and even in the food we eat. There are also sources of radiation from man-made radioactive materials, as well as radiation facilities. Regular monitoring, proper handling, and safety practices, ionizing radiation can be harnessed to benefit humanity. But still, too much radiation can be dangerous to our health. So how can we avoid being exposed to too much radiation? Protecting yourself from radiation can be very tricky. You see, we can't see radiation. You can hear it, smell it, taste it, or touch it. Not with your five senses anyway, but it's there, like a ghost. So we'll need a sort of sixth sense. I see radiation. Our handy-dandy radiation detectors. There are many kinds of equipment that can detect radiation, or will at least tell you how much dose you can acquire. We have survey meters, contamination meters, personal dosimeters, and so on. That's actually pretty fancy. Except there's one problem. They're pretty expensive. We find this equipment in hospitals, industrial plants, and research facilities, where radiation workers can safely use radioactive materials. Policemen, firemen, and military personnel also use them for security purposes, as well as emergency response. But most of us are just your average Joes, sipping our cups of coffee. So there has to be a simpler, more practical way for us to protect ourselves from radiation. The most important of which is the trefoil sign. As we mentioned in an earlier video, a trefoil sign means that the object or area labeled has nuclear or radioactive materials. Now that you know where the source of radiation is, it's time to practice 3 simple steps. Minimize exposure time, maximize distance from the source, and use shielding. Minimizing time is pretty straightforward. Do not stay too long near the radiation source. The longer you stay, the higher the dose of radiation absorbed. Just like being in a toxic relationship. In short, it's directly proportional. Maximizing distance is also obvious. The farther you are from the radiation source, the less radiation dose you will receive. Just like being in a toxic relationship. But there's more to it than just being inversely proportional. In fact, maximizing distance is more effective than minimizing time, because it follows the inverse square law. For every unit of increase in the distance between you and the radiation source, the dose is reduced by the square of the increase in distance. So if you increase your distance by 2, you reduce your radiation dose by 4. If 3, then by 9, and so on and so forth. That is because as you go farther from the radiation source, the energy diffuses over a wider area. Kinda like when you pull a flashlight away from the wall. The farther you pull it from the wall, the larger the ball of light becomes. But it also becomes much more faded. And finally, we go to shielding. Different kinds of radiation require different kinds of shielding. Alpha radiation, which comes from uranium, thorium, and radium, has the same mass as a helium atom, with 2 protons and 2 neutrons. Since it's a large particle compared to other kinds of radiation, it travels slower and can hardly penetrate paper or your skin. But let's not get too complacent. Its large mass means it can cause damage greater if it can penetrate. It's an internal hazard, so while it cannot penetrate the skin, you better hope you don't inhale it or ingest it. It will damage your internal organs. And since it cannot penetrate much, it's difficult to get out of the body as well. Now let's talk about beta. Beta radiation, coming from strontium or tritium, has the same mass as an electron. It's much smaller than an alpha particle, and also travels faster, almost as fast as the speed of light. This means that it can penetrate slightly further than alpha radiation, but it also causes less damage. Aluminum and other light materials can shield beta radiation. However, beta particles could also interact with the materials they hit, producing other radiation such as gamma rays and X-rays. Emitted from cobalt or cesium, gamma and X-rays are not particles, but rays. Duh. As discussed in the previous episode, they are part of the higher end of the electromagnetic spectrum along with visible light, microwaves, and radio waves, among others. As ionizing radiation, gamma rays and X-rays are way more penetrating than alpha or beta particles, as they don't have mass and are traveling at the speed of light. However, they can cause less damage than alpha and beta particles. But like we said before, too much exposure to these rays can also cause health hazards. Since they are very penetrating, we will need heavy and dense materials for shielding such as lead or slabs of concrete. And finally, we have neutrons. Neutrons are particles same as protons or electrons. However, they are very penetrating, even against concrete and lead. We will need hydrogenous materials such as water to slow them down. And there we have it. Use some radiation detection equipment, watch out for the trefoil sign, minimize time, maximize distance, and use shielding. Protecting ourselves from radiation will come a long way towards ensuring the safety of the workers and the general public. More importantly, keeping ourselves safe from radiation will allow us to harness radiation in many beneficial applications, such as in agriculture, medicine, industry, and the environment. Like this video,